Hi there, this video is about the long-run equilibrium of Monopoly. In our previous video, we learned about the short-run equilibrium of Monopoly and we did it numerically. And here again, the approach is numerical in nature. Primarily, we'll see the diagram of it, the theoretical approach of it, and then we'll solve it numerically. Before we go ahead, I encourage you to subscribe to this channel so that more and more people could benefit from it. And by clicking the bell icon, you can receive all the latest videos. So this is the topic that we are talking about. It's about the long-run equilibrium and how the monopolist will make profits or lose profits in the long run. But as the common wisdom and the theory guides us that monopolist is likely to earn profits even in the long run because the entry is not easy or perhaps nearly impossible for the other firms. And we know that in the long run there has to be equality of marginal revenue and marginal cost for the sake of equilibrium. However, in this case we are talking about the long run marginal cost that will give rise to equilibrium. Now let's consider the diagram of it. Definitely on y-axis we'll have the price and the cost variance, and on x-axis we have the output. And we already know that this will be the demand and this will be the marginal revenue functions. They are both negatively sloped. And in this case, you see that long-run marginal cost curve and long-run average cost curve, they are there. And in their background, there is short-run marginal cost and short-run average cost curve. Because we know by the concept of envelope curve that the long-run versions are developed with the help of the short-run versions of the costs. Now this is that point that is giving us the intersection of marginal revenue and the long-run marginal cost, giving rise to this point on demand curve. And this will give us the equilibrium price, and this is the point of the long-run average cost curve, due to which we will consider this point as the cost, the per unit cost. This is the disparity between the two and the profit per unit, and this is the output that is being sold. So all of this brown or gray shaded area will become the profits of the monopoly, and you can see that they are representing an abnormal amount of the profit. So this is how it happens even in the long run as it happened in the short run. Here this is the specific coordinates or vertices of the profit area. And now we are going to consider a numerical example so that we could understand it in a more quantitative way. We are considering a cost function which is mentioned in this equation here. This is the total cost function dependent upon the output, and we are also given the market demand curve which is here as a function of price, and we are interested in the value of P here. The reason is that the profit is a function of output, that is Q. So cost function and revenue function, both of them should be in terms of Q, so that we could take the difference, that is revenue minus cost function. Or in the marginalistic approach, we can equate marginal revenue and marginal cost. So again, we need the cost and the revenue versions of the monopolist. So it will be in terms of Q, that is the couple of these functions. So total cost function is already in terms of output. We have to transform the total revenue function into the marginal revenue function. So for that, we developed the price function in terms of Q, which is the inverse demand function. We developed it from this equation simply by extracting the value of P. And then we have multiplied this P function with Q so that it becomes total revenue. So after developing the total revenue function, which is mentioned here, we are going to develop the marginal revenue function from it, which is written here. And in the same way, we can develop the marginal cost function simply by using the derivative of the cost, that is the total cost function. So here we did this, and we can see that the marginal cost function will be visible here. This is the marginal cost function, and we are going to use this marginal cost function in the equality of marginal cost and marginal revenue function, and you will see that it is the equality of the two from where we can extract the values of Q. And we have only one value of Q right here, that is 1485, and this is the equilibrium value of output, that is the output that is maximizing the level of profit. We can also find the equilibrium price by using the price equation that we developed above, and this is the equation that we had, and here if we put the value of Q as the equilibrium value of Q, we'll get the equilibrium value of price, and it is equal to this, that is 33.5. We have the equilibrium value of output as well. Now finally, the main thing, that is the concern of the profit. monopolist, and that is the level of profit. For that, we can easily substitute the values of Q wherever it is appearing. The value is appearing in multiple places. This is the total revenue function, this is the total cost function, and we have substituted the values wherever they are substitutable. And primarily we have simplified this expression and it becomes this, and now it is a consolidated version of the profit function, which is a function of Q. And after putting the value of Q in multiple places, we have the equilibrium value of profit, which is 32,550, and it happens when the output is 1,485 and when the price is 33.5 units. So in this way, we have concretely solved the situation of a monopolist by using a numerical example, in the background of which there is this theory and the diagrammatical depiction of how the monopolist functions in the long run. And this is how we have completed this. If you have benefited from this video, you may give it a thumbs up. Thank you.